Okay, today we are adding and subtracting square roots. So today's learning target, I can add and subtract square roots. And before we start doing that, I want you to think about what did we have to remember when adding and subtracting polynomials. So think for a minute about the method that you did in order to answer a question like this. And remember that we had to combine like terms. So the x squared could only be combined with the other x squared, the 3x with the minus 4x, and the plus 5 with the plus 8. And then you paid attention to the fact that it was plus in the middle. So we had 2x squared plus 5x squared is 7x squared. 3x minus 4x is a negative 1x. And 5 plus 8 is 13. And so we got our answer, 7x squared minus x plus 13. Well, just like with polynomials, when we have to combine like terms, when we are dealing with radicals, in this case we're just looking at square roots, we have to combine like radicals. So we are combine like radicals. Now, when I say to combine like radicals, they have to both be square roots. So if one was a cube root, I couldn't combine a cube root with a square root. The other thing is they have to be like this part that's underneath the radical sign is called a radicand. So the radicands have to be the same. So if you have 3 root 5 plus 2 root 5, it's actually just the same process as if you had 3x plus 2x. So 3 root 5 plus 2 root 5 is just 5 root 5. So it's that easy. So again, think about what you did when you did 3x plus 2x and got 5x, and that's the same process. So not too hard when they're alike. The question is, what do you do if they're different? So in this case, I have a square root of 24 and a square root of 6. Those are not the same, so I can't combine them. But the question is, can I make them the same? So we're going to do like we did yesterday, and I'm going to break this down. So 24 I can think of as 6 times 4, and I'm going to break it down to prime factors. And since I'm doing square root, remember I have to have 2 of them, 2 factors, to bring one out. So I can bring a 2 out, and since there's already a negative 3 there, that's going to make this a negative 6. And then what's left, I have a 2 and a 3, so I multiply those together and I get 6. So my negative 3 root 24 simplifies to negative 6 root 6. So again, my process, I did a factor tree, I broke it down to prime factors, and since it's square root, I needed 2 repeated factors in order to bring a factor out. So I brought out a factor of 2 times the negative 3 was negative 6. This 2 times 3 had to stay inside because there were no pairs to go with it. And this I don't change, negative root 6. So I have negative 6 root 6. Remember, this is like having a minus 1 root 6. Negative 6 root 6 minus root 6 is negative 7 root 6. Again, just like negative 6x minus x would have been negative 7x, same process on this problem. Okay, for our next problem, 4 root 5 plus 2 root 80. Again, they're not alike, so I want to try. Now, I know I can't do anything with the 5. That's a prime number, which means it can't be simplified for the square root of 5. But I know I can do some simplifying here. So we're going to think of 80. I know 5, well, let's start with 8 times 10. And I can do 2 times 4 and 2 times 2. And over here, I can do 2 times 5. So now remember, I'm looking for pairs. Since I'm doing square root, it takes 2 factors to bring one out. So I can bring out 2 2's. So the 4 root 5 is still going to be 4 root 5. Remember, I already had a 2 out front. I'm bringing a 2 out and another 2 out. So 2 times 2 is 4, times the 2 that was already there is 8. and I have a 5 left over. Remember, I don't have a 4 left over because that got broken down into a 2 times 2. So I was just looking at the prime numbers that I had left. So 4 root 5 plus 8 root 5 is 12 root 5. And that would be my answer. All right, on this next problem, don't let it bother you that there's 3 of them, because we're just going to still try and simplify the radicands so we can get them the same. They're all square roots, so I don't have a problem. Actually, I'm just having you do square roots today. So here we're going to start by factoring this. We'll have 6 times 4, 2 times 3, 2 times 2. So that means I can bring a 2 out. The 2 and the 3 have to stay in, so I get negative. The 2 that comes out gets multiplied by the negative 3 that was there. So I get negative 6. 2 times 3 is 6. Plus the 3 root 6, there's nothing that's going to work to simplify. That's just 2 times 3, so it won't simplify. It won't have any pairs of factors. And for this one, I have 4 times 5. Now, you can continue to break down this 4, and that's fine. I've talked about that. But I also want to remind you, the square root of 4 is 2. So as soon as you recognize that this is a perfect square, the square root of 4 is 2, that tells you you can bring a 2 out. So I'm going to have a 4 out front, because the 2 comes out, times 2 is 4. And then I have a square root of 5 on the inside. But if that bothers you to do it that way, remember you can continue to break it down. I have 2 2's, so I can bring a 2 out, and I get 4 root 5. So now this is what I'm left with. Remember that radicands have to be the same. Well, I won't be able to do anything with the 4 root 5, but negative 6 root 6 plus 3 root 6 gives me negative 3 root 6 plus 4 root 5. So that would be my answer. Just like sometimes you can't simplify, like on that very first problem we looked at with polynomials, I can't combine the x squared and the x. Well, similarly, I can't combine the root 6 with the root 5, so I would stop there. This last one, again, don't let it bother you that it looks more complicated. We just have more steps. So here I'm going to start by doing 4 times 6. And I'm actually going to think about this and say the square root of 4 is 2. So I'm going to, because really when I break it down like this, I'm really saying that the square root of 24 is the square root of 4 times the square root of 6. Well, the square root of 4 is 2. So 3 times 2 is 6. So I get 6 root 6. And I'm going to do this one the same way. So I can think of 54 as 9 times 6. But remember, it's really the square root of 9 times the square root of 6. The square root of 9 is 3 times the 3 here makes this minus 9 root 6. Can't do anything with the 3 root 2. But 18 I know is 9 times 2. So remember, it's really like the square root of 9 times the square root of 2. The square root of 9 is 3 times 2 is 6. Can't do anything with the root 2. So then I'm just going to combine like terms. So 6 minus 9 is negative 3, so I get negative 3 root 6. And negative 3 plus 6 is positive 3, so I get plus 3 root 2. Now if you're going to do this method, which I would really say is a shortcut method, and some of you will like to do these in your head, and it's a whole lot easier if you just think about what's the biggest perfect square that goes into those numbers. So it might help you to think about perfect squares, like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, then we have 25, 36, 49, 64, 81, and 100. Those are the perfect squares up to 10 squared. And then you're just thinking, what's the largest perfect square that goes into 24 evenly? Well, it's 4. 4 times 6. The square root of 4 is 2, and then you can just simplify it like that. That's usually how I do them, especially if I want to do them in my head, and some of you will be able to do that. But if you need to, just do all the way to the prime factors and look for pairs of numbers that can factor out.